Advanced Math Lesson 30, Addition of Vectors and Overlapping Triangles. So, vectors are the grid and polar coordinate things that we've been dealing with. And we've been expressing vectors in terms of height or of two legs of a right triangle, or we've also been expressing them in polar coordinates. So now what they're going to talk about is the addition of vectors. So they give this first example, this vector 1 is here, and then they have vector 2. If they add them together, pretty much the second vector puts its starting point right at the tip of the end of the first vector. What happens is it ends up drawing this. So the resultant force is going to be the third leg of the triangle. So if we were to have a coordinate plane, right, and then we drew vector 1, right? This is vector 1. Vector 2 would start right at the end of vector 1 on its own separate coordinate plane, right? So vector 2, if it goes like this, just like in the book, it's got its own coordinate plane and it goes this direction. That's vector 2. So if we add these two forces together, the resulting force is going to be at the very end point of vector 2, and it's going to complete the triangle. We call that the resultant. Now, interesting thing is whenever we do negative vectors, that dashed line, if we were to add a vector to its negative vector, that would perfectly put us right back at origin. All right, so that's one of the reasons why in polar form we have those four forms, because it's good to know what the exact opposite form of your vector is. Now, let's talk about addition of vectors and how to do that mathematically. So, example 30.1, they tell us to find the resultant of 4 angular 20 plus 7 angular negative 230. So first thing I'm going to do is I'm going to draw these two vectors on separate plane systems. Not very big, just big enough for me to understand the math. So I've got 4 angular 20. I know that's going to be in here. Angle is going to be 20. Hypotenuse is going to be 4. Okay, that's going to be first quadrant. Now, I've also got 7 angle negative 230. So it's negative 90, negative 180, negative 270, negative 230 is somewhere in here. Hypotenuse length of 70. Negative 180 to 230 is 50. So this is going to be a 50-degree angle in the second quadrant. Now, in order to add these two vectors, I need to convert them both to rectangular coordinates. So you may have been wondering, why do we keep going back and forth between rectangular and polar, rectangular and polar? Polar coordinates tell you much more information about the vector. Rectangular coordinates make it easier for you to work with them, like in this case, adding them. So I need to convert both of these to rectangular coordinates, which means I have to use my sine and cosine trig identities. So my hypotenuse is 4, my angle is 20. So here I will be saying the sine of 20 degrees equals the opposite side, so y over 4. To solve this, I multiply each side by 4. So my hypotenuse times the sine of the angle is going to equal y. 4 sine 20, and parentheses, enter, and I get 1.37. So this is 1.37 I, right? Now let's do J, because that's an elevation, that's a y-axis. So 1.37J, and then to do the length, I would just do 4 cosine of 20, because it's a similar identity. So I take 4 cosine 20, and parentheses, enter, 3.76. So this is 3.76I plus 1.31J. So I've got 3.76I plus 1.37J. That's the first point. Now let's go to this one, the 7 angular 50. And again, the trend here is 7 times the sine of the angle is the opposite. 7 times the cosine of the angle is the adjacent. So I'm just going to skip straight to those. 7 times sine of 50 is going to equal the y. 7 times cosine of 50 is going to equal the x. So let's go ahead and punch these in. I get 5.36. Right, and then I get 4.50. So now what I have over here is I have well, no, I'm going to write that under here. I have 4.50i plus 5.36j. Now here's the problem. This second angle is in the second quadrant. In the first quadrant, everything is positive. In the second quadrant, the only thing that's positive is sine. Now remember, y is like sine, and then x is like cosine. So this should be negative 4.5. Or you could even think of it in x and y terms. If I'm going this way on the x-axis, that's a negative 4.5. If I'm going up, that's a positive. So now what I do to find the resultant is I combine these. I combine like terms. 7 and 6 add up to give me 13. I carry the 1. Got 7, 6.73j. And then, let's see here. Positive 3.76 minus 450. You know, we can go ahead and use our calculator because decimals are difficult. 6 minus 4.5. And you get negative 0.74. So we have negative 0.74i plus 6.73j. That is the resultant force. Now, if we really wanted to, we could take this answer and write it in polar form. But that's a different video and a different lesson. And that's all we're going to learn on lesson 30. The other section of the lesson, overlapping triangles, hinges on proofs and geometry. So we're going to keep focusing on the trigonometry. So that's all there is for that. Yep. All right. I will see you in class. If you have any questions, message me on Moodle.